Chapter 3, Exercise 27. Show that the domain of F composed G is equal to the image of G inverse under the domain of F for any sets F and G. Now, F and G need not be functions. Okay, let's do it. Let's suppose X is in the domain of F composed G. Then there must exist some Y such that X comma Y is an F composed G. Right? So there exists some T such that XT is in G and TY is in F. Now XT being in G is equivalent to saying that T comma X is in G inverse, right? And TY is in F implies that T is in the domain of F, right? So Tx is in G inverse and T is in the domain of F. So Tx is in G inverse restricted to the domain of F, and thus X is in the range of this here set, and thus X must be in the image of G inverse restricted to the domain of F. Cool. So the domain of G composed F composed G is a subset of G inverse image dom F. Okay. Next up is the other way around. Let's suppose X is in G inverse image dom F, right? Then what? X is in the range of G inverse restricted to dom F. It's basically the same proof but backwards. So there exists some T such that, Tx is in G inverse and T is in the domain of F. Now Tx is in G inverse if and only if Xt is in G, and T is in the domain of F. T being in the domain of F implies that there exists some Y such that T comma Y is in F. So there exists some T such that Xt is in G and Ty is in F. Thus X comma Y must be an F composed with G. And this means that X is in the domain of F composed G. So G inverse image dom F must be a subset of dom F composed G. Finally, we conclude that domain of F composed G is indeed equal to the image of G inverse under the domain of F. And there we go. That's all of exercise 27. Pretty short, and we did not assume that f and g were functions. We didn't assume anything about f and g, actually. So, very nice. Our proof should be correct. Anywho, with that said, I hope this was helpful, and I'll see you in the next video. Bye-bye.